Thank you, everybody, for joining us here at the August TRiRODS event. We are welcoming Mike Conway and Patel from NIEHS, who are going to give us some updates on Metalnx, search, and other particular focus areas of their development as how this technology applies to the broader iRODS community. So I believe Mike is going to get started.
Sure. Okay. Right.
Thank you, Mike.
Hey, guys. Thanks, Jason. So we started with stealing some slides from something we presented to the iRODS UGM on the GA4GH stuff. So some of this you may have seen. And we're at the Office of Data Science at NIEHS, and there's actually little offices of data science that seem to be appearing across a lot of the ICs at NIH, and we are internally working on what we are calling a commons. It's kind of a loaded term these days with NIH, but think of it more as an institutional repository where we are managing all of our research data. So NIEHS it's a laboratory, it's a research laboratory. So they are actually doing experiments and doing sequencing and doing all kinds of sciencey stuff, and we're managing all the data that comes off of the intramural research. So our data commons, again, is like managing all that research data. So we're really involved right now with especially working with our epigenomics core and all the data coming off of our sequencers, processing the data as it comes off of the sequencers and running pipelines on that data and then depositing it in our commons. And we're doing things like now trying to have like an ISA project model where we can link the scientific data to the projects and purposes to which they're being used. So you could do things like search for all data sets that are looking for a specific gene or working with a specific species or some sort of chemical substance, things like that. So a lot of this is integrating search and extracting metadata from different parts of the process. We've been really interested in tracking what GA4GH is doing. I think this maps well to a lot of our concerns. So they have a model about abstracting out tools. Think of Docker images and that are doing particular things out on somewhere like DocStore. Workflow execution services, that's a place where you're running a workflow. So for those of you who dealt with the NIH Commons, this whole notion of having a workflow that can run on multiple clouds, then that's sort of what WES is about. Task execution service is about running a specific task on at a particular location. So, I'm going to run a workflow and this task runs on Amazon, this task runs on Google, this task runs in-house. And then now they have this data repository service, which is a way to surface data to these workflows from arbitrary locations. And we were just talking with Patel and Jason, and we're going to be demonstrating a DRS, data repository service endpoint here for iRODS at the GA4GH plenum in October. But we are looking at it because we want to start being able to lay some of these other elements on top of that. So that's kind of what we're about. So what interfaces are we talking about? And our focus here today is on web interfaces, and there's actually a lot about REST API here. We're not getting into the guts of the REST API, but you'll see where sort of our reliance on REST kind of comes in. And then with the data repository service, with things like NFS, more and more looking at standard protocols and interfaces that we could implement under. I've heard noises about CIFS and some other things too with iRODS. So that's really what we're about. So web interfaces, we've had these talks over and over again for a long time. So let's talk about that. So it's been a tough road. So one of the first things is it's really hard to get a consensus about what a web interface looks like for something like iRODS. Even among ourselves within this building, it's been hard to get this consensus. Okay. It's also hard to find resources because I've come to find that writing API, writing services is easy. Writing GUI interfaces is maddening, time consuming. And if anybody's had that experience, I think that writing good UI is one of the hardest things that you can do with computers. Okay, and it's hard to, but it's hard to develop something that is generally accepted and useful across multiple use cases. Okay, so that's why it's been tough. Those are some of the reasons why it's been tough. Okay, so we've had a couple, like way back in the original DICE, there was iDrop Web 3 and iDrop Web 2, which are actually still pretty boss. They're still running at Lifetime Library, by the way. Some joker, I don't know. Then we had the cloud browser, which actually was actually promising, but it was promising, but it only had like a subset of features. But it had some good qualities. And then we had, with Steve Worth and the folks at Dell EMC, they were gracious enough to contribute the Metalnx code base from Dell EMC into the iRODS consortium. And I think there was a general feeling that, you know, maybe not looking for something that solves everything at once, but rather something that at least is a pretty good rational starting point from which we could go, like a beachhead. It seemed like a pretty good notion, and I think it has been a really good notion. So right now, this is here in iRODS contrib. So it has pluses and minuses like everything else. So on the plus side, it's a thing that has some small amount of consensus at least, and on the minus side, it's not XYZ, choose your favorite language framework, yada, yada, yada. That's always going to be. Out of the box, it's got lots of interesting functionality, especially on the side of administrative tools and some of the extended user functionality that I think points to a lot of things that are worth looking at. On the minus side, it has an opinion about how some of these functions work that are not well defined in the core iRODS. I think this is right now the biggest impediment to Metalnx adoption. On the plus side, it's using basically vanilla enterprise constructs and frameworks that you would find if you went out to an IBM or something like that. So it's built on an enterprise level stack. But it has this kind of mixed approach where it's mixing some of the things it does with Ajax-based things that cause some occasional inconsistencies that we're kind of still trying to wrestle down to the ground. It's really super stable. At NIEHS, we run it for months. We run these in Docker images and it'll run for months without touching it. It's really been super stable. It's hard to initially deploy and configure. Okay, so that's something that we're really trying to work on now. So it's a good starting point, but it has some technical debt we're trying to manage. And some of what we're talking about today is efforts to start managing that technical debt and kind of shape it in a certain direction. Okay, and by we, I'm talking about anybody that will help participate, send in pull requests. This is a community thing. So, you know, we talk about it a lot, but we are definitely not interested in NIEHS kind of like steering this boat. It's like we're really trying to get to a point where consensus builds, right? So what are some of the things that have been going on? If there's a little bit of turbulence in it right now, I would still say, between 1.0 and 2.0 and then continuing. So there has been an initial attempt at actually simplifying and drawing down the scope and the functionality that's in the system. So we're hiding some functionality right now. And a lot of the stuff, when we say we're hiding it, there's now configuration that says turn this part off. So we're not ever taking anything away, but we're generally saying and recommending turn these parts off for now. So like the dashboard and some of the administrative dashboard stuff. And then we're also, and this is really key, trying to migrate functions that were specifically implemented as Metalnx services with Metalnx database support as much as we can into iRODS core server functionality, right? So for example, there were some things out there about user group and user management, especially in the case of federations. And this is a place where the database maybe is getting in the way. So the thought is, why don't we see what we can retract and make it more just talk iRODS things, right? So where is the database really adding value is a question, especially as we try to have less Metalnx opinions and more iRODS opinions. Right, and then simplifying the app structure. This is something you'll see now in the master branch. So it used to have like 6 or 7 sub-projects with pieces scattered. So we've actually merged that all. So now there's just one Metalnx project. But in part of that, we've extracted services out of Metalnx. Okay, and so we had this thing. No, I'll hold. Can you see the webpage?
No.
Okay, then we'll forget about that. There's some links in these slides if you look. But what we're trying to do is Metalnx has web controllers and views, but it also has a service layer. So we are extracting that service layer out of Metalnx, and we are facing it with some standard abstract interfaces. So the notion would be that then you can start pointing Metalnx more to these abstract interfaces, and then underneath start, for example, with users and groups, instead of doing this thing to the database, let's do it against iRODS, right? So I think something similar is going on with the server architecture too. So this is kind of a common thing. So lift this up, take the service layer out, add a shim that's like organized as abstract interfaces, and then but we're doing that while the thing is moving down the road. So the services become more universal too. So one of the points is, as we create services, they're not necessarily surfaced through Metalnx. They could be surfaced through another API, another interface. And so you don't want to have two opinions about how a favorite looks, right? So you take favorites out and then you make it a thing. So gradual refactor underneath, and there's also an issue with circular dependencies sometimes in the builds, and so we've done a lot to alleviate the circular dependencies cropping up. So this is where it gets fun. Okay, so migrate existing features to more widely accepted applicable features. So one thing, and we were just talking about how we've talked about metadata templates for a long time, and Metalnx actually has in it metadata templates as an implemented feature that goes to their database. And so now what we're doing, and this is a great example of this refacing things and then changing the underlying implementation, is what we are doing is trying to plug into the metadata templates working group, which again has really kind of taken off with some really concrete implementations based on existing code. And then we want to put that underneath these abstract interfaces and surface the metadata template support that's going to be in iRODS through Metalnx and kind of unify those two efforts. So Metalnx just really becomes a way of visually looking at and curating data with these templates, where everything else is exported into iRODS or into Cedar or wherever it goes. So we want to do this for other non-core functionality, right? So internally, the things you see, we're moving towards open API, Swagger, and microservice architecture. So things that Metalnx would look at, like the metadata templates API, we want to see represented as a microservice architecture and just call it through a REST API. And this really works well too towards making things configurable and language independent. So in our example, Metalnx is a Java-based platform, but our search stuff is all done in Python. But so it makes it really easy to mix languages through the microservice architecture, and you can use what is appropriate. Okay, so overall strategy. Continuing, like try to use Metalnx to bring community innovations and shape as widely applicable features. So this is where we're looking out at other interfaces and starting to try to steal what they're doing. And I know Tony's on here, but one of the first things we did is we went to the DE stuff and we stole the API and the database schema for the notification subsystem. So, and we'll talk about that in a second. We'll talk about some of these point things. So this is an example of, well, they're already doing this and it actually works pretty well. So why couldn't we just take notifications and make Metalnx use that? So it's not coming from iRODS, but it's coming from the community, right? Use Metalnx as a tangible basis for discussing new client capabilities. And so this is where, and this is really what we're highlighting tonight, is this pluggable search. I think it's a really great working example of what we're proposing here in terms of going forward. So we'll talk about that in a second, but we want to start migrating these abstract interfaces as being reflected or embodied through callable REST API microservices. So piece by piece over time doing this with Metalnx, but then you can start again surfacing in other places. So there's some developer workflow enhancements that are in the master branch right now that if you're following that, you may have noticed. Okay, so one, we've collapsed the code base. There's just one project, one folder that has all the code for Metalnx now instead of 5 or 6. So the common services are extracted out. There were some things we did to make it skinnable that we basically did because we had to skin it. That in retrospect, it's like they work, but there's better ways of doing it. So there's a feature in WAR applications, web applications, called a WAR overlay, where essentially you can just call this WAR file as a dependency and then just change particular pieces of that application. So if I want to add even a new controller or a new view, I can just extend the WAR and just add my controller, my view in place and basically overlay selectively parts of the application. So there are some systems like CAS, for example, that do exactly this. There's a vanilla CAS, but then you can, through their WAR overlay mechanism, just completely add new sections to the application. So that's where we're moving as well too. It makes it easier. So migrating services into pluggable microservices. So starting to have like a standard way of using JOTs within Metalnx to talk to microservices and do some of that. Open API specs and containers. And again, we're maximizing iRODS things and minimizing Metalnx things, especially this database, which you'll see get smaller and smaller over time. And also we are moving to Vue.js, and if we have a second, we'll show that. But essentially Metalnx is done using time-leaf, so it's actually rendering templates on the server side. And Vue is a JavaScript framework like React or like Angular. A, it's simpler and cleaner, and B, Vue is really good at this sort of gradual employment. So what this means is that if you have a major section like browser or search or metadata editing, there's a page that's being rendered from the server for that. So now what we can do is just say, okay, from now on, this page is actually going to be a Vue app. This page, and so you can have these existing pages are the time-leaf framework. This new page will be a Vue app. So you can actually take parts of Metalnx now and start moving it towards like a more Ajax kind of thing. And this is going to be one of the main things we want to do is speed up and enhance the collection browsing and take some of the things from Cloud Browser. Okay, so notifications, you can see here's a link here to their API. And we're using it for 2 use cases right now. So we have this notion of you can search for data, and even if you can't find that, even if you don't have access to the data, you might have access to the metadata. So what we do is you can turn on a feature that says, I can see the proxy page for this data, and I can see the metadata I want to show, and then there's a button that says I want to request access to this underlying data. And so the way this works is that they request access, I request access, Deep gets a notification, he can allow access like just through the interface. So it's really good for requesting data access to things you find by search. And then the other thing too is we're tying it into our pipelines, so that when data is run off the sequencer and it runs through our pipeline, it's delivered into the commons, we can start notifying the PIs and the analysts that this data is available, which actually also helps drive people to start using the commons by using it as it, right. We're not going to go in detail on this, and I'm showing this is our API, which, Tony might recognize some of these endpoints. But the notion is it's a container, so workflows can post or put to this Docker image just out of the CWL or the Nextflow workflow, and Metalnx can pick it up. This is how they do it in DE. You can see the upshot, and we actually have these artifacts in Metalnx too. Is here's like their little notification message center, and you click on it, you can see things like here this pipeline is run. Click here for your data once your access. So that's a notion of one way we can start leveraging what other people are doing. Metadata templates too. I'm just going to wait. Yeah, go ahead.
Is there any policy wrapped around those notifications?
No.
From like a rule language policy, I mean.
Yeah.
Data is put into a collection, data is removed from a collection.
Right. I mean, what would be interesting, since it's just a REST API, would just be to have some Python rule engine code or some little functions that allow you to push a message from a PEP.
Oh, yeah.
Seems like that would be, yeah. And, for all I know, even Cyverse maybe has some stuff like that already in their rule base. Because again, the endpoints in the database schema are pretty much identical. Deep, is that still true?
Yeah, this was just a kind of prototype that we did last, like in this year, but we didn't. So because of Metalnx being time-lift and everything, and we were moving towards Vue, so we have just stopped it working on it right now.
Yeah.
We're focusing more on search right now.
Right.
Sure.
But the code is out there, and yeah, it's just a Docker image, so you could fire these up and we use the Metalnx database to hold the notification schema. Metadata templates is a TRiRODS all in itself, the current status. But the notion is that you can, instead of having bags of raw AVUs, you can define templates as JSON schema. Here we're showing that you can use the Cedar interface to create a template. You can then bind them to collections to say like anything in this collection has to have this metadata. And then what we want to do in Metalnx is leverage that to present tools for data curation so that you can actually fill these forms out. Store the metadata AVU and all the validation and management can be done by iRODS. But then you can retrieve those templates, merge with the AVUs so that you can do nice user displays. Instead of showing just rows and columns of AVUs, you could show, you know, something appropriate to your installation. And then also allow editing of that metadata again. And interesting too, once you have your hand on the template, you could create new search interfaces based on the template too. So I can also use the templates to create a search template, which is kind of what we really want to talk about tonight. Search, okay. So we want to do something at looking towards leveraging the indexing capabilities that are coming out in the consortium, right? We want to be able to allow custom search schema, which means we have epigenomics, we might add cryo-EM or mass spec or something like that. They have totally different ways of indexing and searching for their data. So we want to be able to plug in new schema. And we want to do this in Metalnx without hard coding things, right? And so we're kind of inspired by looking at PubMed, which kind of Maria steered us towards. So in the PubMed model, you kind of go to their search page and then you can pick what schema you're searching. So I want to search cryo-EM, I want to search mass spec, I want to search, what's another sciencey thing?
EDI?
Yeah, okay, I want to search as a different persona, right? So you pick the schema. We're jumping around a little bit, but in a schema, there are attributes associated with that schema, right? So if I'm searching epigenomics, it might be, you know, assay type, it might be species type, it might be who was the PI, you know, those kinds of things are how you want to search. And then when you search PubMed, you get a display that looks Google-ish, right? So you have, you know, sort of semantically, you have like a title and there are links involved and you might have some descriptive text, but then there's also different kinds of links that can be associated. So an example for us is if we search projects, you might search the hypothesis, for example. You would get a link to the project proposal with all the scientific matter. And then underneath that, you might see all the different runs or all the different assays that were done like in furtherance of that project. So you could have that view for project search. If I'm searching what we're calling like sample search, I might enter a sample ID. And then what I would get would be the epigenomics run folder that contains that sample. Or, you know, it may be that sample is used across other assays, right? So, depending on the schema you search, you might get like a different result, but that it kind of looks the same and it has the same major page elements, right? Think of it that way. Okay, and Deep is going to actually demonstrate this. So we have a search API following the same thing. It's a Swagger-based API, and it has the notion that you can create one of these endpoints for whatever search schema you want to provide, right? So what is in that API implementation? It is self-describing, so I'm an endpoint, I will tell you all the schema I support, right, and things about them. Then I will be able to tell you also the attributes that each schema has in it and what they mean, right? And then I can send a search to that API in 3 ways. So first is I can search free text, right? So I just said glioblastoma, cell, and gene as words. Okay, so there you're just searching free text. And so we're targeting Elasticsearch. So as you know, Elasticsearch has a schema that has different elements in it. So part of what this API does is it does translation. So if I'm searching projects, a project is like a proposal letter that has hypotheses, a scientific method, it has backing references, it has data analysis strategies. So you have these different elements. So when I search a project, we may say we want to search title, hypothesis, and the reference data. I reference this paper. And so if they just type free text, you might decide I'm going to attack these parts of the schema using like a fuzzy search or using these sort of parameters. So there's some tuning of what the user's saying and how that's translated against your schema. The second way you can search it is you can post a search that has attribute, sort of advanced Google search, little twiddly flags that are different per schema. And then there's help that comes from how this thing describes itself about what these things mean. And then the third thing is using those attributes to do builder style queries, where you can actually see the attribute, add an operator, and or those things together. And Deep's going to show that in a second. Okay, then the API interprets those searches and translates them to the appropriate DSL. So again, think of the search schema as really who's the persona doing the search and what are their purposes. So it gives you a chance to take a simple search and maybe do something more complex under the covers with an understanding of what your user is doing. So again here, search hypothesis and project description is free text with fuzzy matching. Search sample ID is an exact match. Okay. And then we want to return queries in two formats. One is this Google-like result where really you're giving like the semantic meaning of like title versus the textual description versus like a see also link, etc. And then we do want to have like a row column query listing so that we can do vertical collections where you store the query and then you can use it as if you're doing like a file listing type query. Okay. Then the nice thing is we get away from trying to do plug-in jar files to Metalnx. So this is an example of how you would plug in search. And so it's hard to see here, but on that slide, maybe you can see that the search is enabled true or false. So by default, this can just be turned off. So you don't even see it in Metalnx. But if you just turn it on to true and then you configure like a comma delimited list of endpoints, the URL of each endpoint you want, when Metalnx fires up, it now goes out and it can pull all those endpoints and gather all the file schema. And then as you select a schema, gather the attributes, and it's caching along the way, right? And then the notion that, so based on the configuration, initialize and ping the endpoints, cache the schema info, and then call search and present the results. So all Metalnx is doing is figuring out where the endpoints are, doing the drop downs, and then displaying the results in one of the two formats, okay? So this is working now in everything. We're all the way up now to just doing the UI components. So there's an example implementation out there. This is in Python. There's plenty of room to take this implementation and extract out more abstract library support so that maybe you define your schema and your attributes using a JSON file or start doing fancy things. But right now we're just doing a direct implementation. And that's where we're starting, and maybe we'll learn like how the API goes. And I think Deep now, do you want to show some of what this looks like?
I think it's doing the whole screen, so you just flip it.
Yeah.
Or you can stop it. Yep.
So what I have in my background is running so we have a Docker container which has plain Elasticsearch, and just for test cases, I took. So it's running this Python Flask in it. And just for test examples, when Mike told about a project or a sample, we have to index it and create this document. So each project will have one indexed document, which is basically a JSON and which contains all the metadata in it. So there is a Docker running in the background, which has, so this JSON files are added in that indexes. And right now we have two indexes. One is project and one is samples. And so to make this work, we need a JOT token, which will be minted by Metalnx. And this is the search thing running Swagger. So for every call, you have to use the JOT token to as a header to get authorized. And so as I was saying that we right now in the demo, there are two indexes. One is project, one is samples. And now if we do a generic search, it requires two things. One was in the dropdown from PubMed, you need the index name, which can be projects over here, and a search value, which can be, and it will return this is still a demo. So the first part is the description of the index itself. Second is a search result, which is once again a URL to a data object. And so there are title, there is a URL, and there is a content text, which can be used to create that description of the search. And we can add some more functionalities to it. So if I want a specific search, so once again, this is still a generic search, and we have not worked on an advanced search, which can be a auto-populated form using the index schema itself, where if there is a date field in the schema, we can give a date range to the user directly, and then DSL can be formed in the backend using a data type. If it's a date, it will be a range. So, but it does support a specific. So if I want to search a project ID which contains test with a fuzzy match, and so it will return the result basically.
So that URL is a.
So URL is the link to the Metalnx, or so it has a iRODS data path.
Mm-hmm.
So if a user can click on it, it can directly take them to the Metalnx data path. So
Right, so we wanted to have enough elements in the standard, like if you know, defining the standard for how you return data.
Mm-hmm.
So if we wanted a project, we want to see a link to all its runs. So you'd want to see like see also links like in a list. So you want to have like enough richness to what the UI will show, but give the search results like a meaning that is visual versus semantic for the particular domain you're looking at.
Sure.
You know, that kind of thing. So we're kind of wrestling with that right now.
and once again, it's in the service layer, so it's nothing hard-coded right now.
Yeah.
So
Yeah.
and if you want to just show the notification, it's still running as well.
Why don't you show that?
Okay. So basically, the notification that Mike showed, it's still, we didn't work JOTs or anything with it, and it was like this. If there is a username test one, if there are notifications sent to them. Okay. So like this, it's once again a message with a timestamp, seen, unseen, deleted.
Yeah, different types like that. So these are, yeah, so the notion here is that Metalnx is really like starting to really lean on assuming that there are REST API underneath it. And so developing in Metalnx really becomes more about trying to define and develop these interfaces, especially as they evolve with what's going on like in the consortium at large, because we really want to track that, right? Oh, so here's like the other thing, right? I was talking with somebody today too, and here's something that's really important as we start talking about these interfaces, is to talk about streaming. So these are all the guys that are doing streaming kinds of things right now, right? And that this is kind of like a plea saying, hey, you know, we're talking about the multi-part transfer, right? Which is like awesome, but one of the, maybe even more important than that, I don't know if that's an exaggeration, is to start really looking at extracting maximum performance out of the streaming IO so that all of these guys work. It's coming. It's coming. Yeah, I know it's coming. So I guess what I'm saying is like, just like with the, in the metadata templates working group, there's discussion about having an atomic method for bulk manipulation of the AVUs like within a transaction. And so that really may turn out to be like a key enabling feature of iRODS that all of a sudden interesting things are built on. And like, this is of the same type, right? Which is like streaming IO performance. Thank you. So anyway, so that the search was really about a really good example of all those pieces of like how to approach interfaces, right? And there's really, you notice there's very little GUI talk, and there's a lot of talk about how these services are decomposed. And like, you know, the consortium is doing this really good job with patterns and capabilities to start, you know, it's really about thinking about capabilities of things that are surfaced in typical clients when you're interacting with a cloud data store, right? How do you favorite a thing? Like, everybody has a different opinion on what's a favorite, right? And so it's really kind of a notion of Metalnx as a way to start thinking about this. I mean, the GUI doesn't really matter. It just doesn't, right? What matters are the capabilities, and can we have a GUI? The reason we don't have a GUI that everybody can agree on is because we can't agree on these sort of fundamental artifacts. What is a bookmark, right? So that's kind of what I want to say. But so Metalnx, it is kind of being pulled apart while it's running. So there will be some turbulence in there, but I think there actually is a point and some stuff is happening. So does anybody else want to chime in either with questions or about other client stuff? Talk about NFS?
Two people in the computer too.
Yeah.
We have any questions here? Are there any questions in the computer?
Not from me, but thank you. It's insightful.
Is that, hey, Tony, how different is that from the search that you guys are conceptualizing now?
Oh, I don't know. We're using what you just did as a jumping point. Well, that combined with what we have. So
yeah, I'm sure you guys are.
Ideas.
Cool. Okay.
So streaming performance, I mean, what does that mean to you beyond calling RS data or RC data OBJ right?
And so that's a good question. I don't know all the answers, but it seems to be a notion of, are there ways to maximize through the use of different buffering techniques? For example, raw stream performance. Have we extracted, do we think, the maximum raw streaming IO performance in terms of what you can do with buffering, or you know, non-blocking IO kind of techniques, or, you know,
Inline compression?
Things like that, absolutely. So like, you remember back in the day, all the tuning we did on TCP IP, that sort of thing. I think it's probably safe to say that more performance could be extracted out of the current system. But I don't know if that's true or not. But
Well, it takes about 3 threads to fill a pipe, as far as we can tell.
yeah,
Yeah.
So with one, you're not doing that
right.
today. But we're gonna get there.
Yeah, I know. I'm just saying, like, I think there are wins to be made by, screaming, single, pipe IO performance as much as there is with the multi-port, right? So, and that's true both for the clients we're building as well as for the server side. So anyways, there's that.
Cool.
All right. Anything else?
How's NFS going?
It's coming along. We're still working out apples right now. So, but I think there's about 2 or 3 issues left, and once that's up, I think we might be talking a 9 release or something.
Yeah,
like
there's
that.
2 or 3 things that we've identified to stare at. And then we'll have a point 9 and show it to everybody else, and somebody else will show up with 1 or 2 things. But at that point, it's 1.0, and it'll just work.
Okay. Well, in this slide, there are links to code and things. All these things are running code, so they're out there.
And we will have the slides themselves. We can post those.
Oh yeah, I'll email them to you.
Okay.
tonight.
Okay. We can put those online as well.
I'll just say one other thing. Like Metalnx has a search built into it for file properties, and then one for ABUs, but they're split. So you can't search on an ABU and on a file size, for example. So one of the things we wondered about was having just an out-of-the-box schema that mates with an out-of-the-box indexer that we could use to just have a standard catalog data and ABU combined. Don't have everything tagged with this, that it was last access mumble.
That's what people expect to see.
Right. But you could do that out of the box and then just have it, you just go into Metalnx properties and turn it on, or go to the search and turn it on. So that would be a neat way to kind of bring the circle together, right? The circle is complete. I think that's the quote from Darth Vader, right? But,
Lion King.
no, Lion King, one of those.
All right. Well, excellent. Well, thank you, Mike.
Yeah, thank you very much. Thank you.